right, here we are at our 6.7 set of notes. We're looking at intercept form with our quadratics. And so really this is the third type of graphing quadratics. And we have f of x is equal to a times x minus p times the quantity x minus q. Now this p and this q are going to represent our x-intercepts. So that's pretty much where your quadratic, that U shape, crosses your x-axis. So as we can kind of see here, here's a prime example of what I'm talking about. You see it happening at P and at Q, and then comma 0 because it's crossing this x-axis. Okay. Now to find this axis of symmetry, well, it's literally just the in-between point of those, at least the x value. So as a result, to find that, we would take the average of the two of these. So you would essentially just take your P value, whatever number that is, plus your Q value, whatever number that is, and then just divide it by 2 to find out where is it at in the middle. And again, that's for your axis of symmetry. And then once you have your axis of symmetry, you can then like find the vertex and all these other items. But for right now, we'll focus on that in a little bit. Same rules still apply. You guys know that when a is larger than 0, that a value is some positive number, your U shape is going to be going up. It's going to open upwards. And then when a is smaller than 0, that's when it's a negative value, it's going to be opening down. So those rules still apply here. And again, when it's in intercept form, that a value is in front. So that's where our a value is this time, much like the vertex form and standard form. So, all right, so let's kind of see this in action with some values. So for example, 1, we're asked to find the x-intercepts and the axis of symmetry for each function, and then kind of graph the general shape of this. Well, what I have my guys do in general is, remember with, when you factored things down and then you solved items, essentially you kind of already have done your x-intercept. So you would break these up and have x plus 1 equals 0 and x minus 5 equals 0. And then to solve for x, you would, just subtract 1 over, boom, x is -1. And then add 5 here. And so then x is normal 5. So our x-intercepts are actually -1, 0, and then 5, 0. So those are our x-intercepts. So now when we go to graph those x-intercepts, when we go to plot those, we just have -1, 0. This is going by 2's, it looks like. So we're going to go right there for -1, 0. And then 5, 0 would be right here. Okay. Now, in general, I do highly promote finding the y-intercept. So we're going to go ahead and do that because most functions do have a y-intercept. So we have, again, for y-intercepts, let's change up colors. For our y-intercept, we know x is 0. So x is 0. So when we plug that in, we end up with negative of 0 plus 1 times 0 plus 5. And so as a result, we get negative of 1 times 5. So then we end up with -5. So really for the y-intercept is 0, -5 for that value. So, oh, that might be. I was like, wait a minute, that can't be right. That +5 is actually a negative. So, I'm like, this U should be going downwards, not upwards. There we go. Okay, so you end up with 0 minus 5 is -5. And then -1 times -5 would be +5. So 0, 5 would be your y-intercept. So when we go to plot that, we end up with, and going by 2's, there it is. Okay. So now we kind of have a kind of shape to this. We found our x-intercepts. We found the y-intercept. Again, these are excellent points to find, the y-intercept included. Now, it did ask us to find the axis of symmetry. So let's go ahead and do that. To do that, So axis of symmetry. To do that, we're going to take our P plus Q and divide by 2 because we're finding the average of it. And this is X equals that value. So X equals our P is this, Q is this. So -1 plus 5 divided by 2. So it looks like 4 divided by 2, which is 2. So our X value, our axis of symmetry is 2. And then recall, now we can create that mirror with it. So remember with the y-intercept being at 0, 5, well, if I'm trying to mirror this, it would be at 4, 5. And then lastly, we can also have the vertex. So we know the x value from our axis of symmetry. So if I want to find the vertex, I know x is 2. I would just simply dump that in. So y equals -1 times 2 plus 1 times 2 minus 5. So y equals -1 times 3 times -3. So in total, -3 times -3 would give us +9. So our vertex is at 2, 9. And that would be about there. So this is our general shape for our quadratic. And then, we connect our U. Okay. So again, recapping for A, we split and solved. We had our x-intercepts. Y-intercept is good to find as well. Axis symmetry, yes, you will need to know that. P plus Q divided by 2, you find the average value. There's your axis of symmetry. Then once you have that, you can find your vertex because you then know the x value from your axis of symmetry. All right, so let's take a quick look at B. Now B is slightly different because it kind of is in more standard form. So to find the x-intercepts, we know that we have to set the y value equal to 0. So that's exactly what we're going to do. And there's a couple different ways you can solve it, but we'll just solve like normal. So we'll add 8 to both sides. Boom, boom. We get 2x squared equals 8. And then we'll divide this coefficient over. And so we get x squared equals 4. And then lastly, we'll take the square root of both sides. So x comes out to be plus or minus 2. So then for our x-intercepts, we have 2, 0 and -2, 0. Now we'll go ahead and plot those values. So 2, 0 would be located right there. -2, 0 would be located right there. Again, the y-intercept, always awesome to find. So for y-intercept, we know x is 0. So we'll use function notation actually for this guy. So h of 0, we're dumping 0 in for that x, equals 2 times 0 squared minus 8. And 0 squared times 2 should be 0 minus 8. So we end up with -8 there. So we dump 0 in, we got -8 as a result. Plotting that. Boom, there's our y-intercept. Now let's go ahead and find our axis of symmetry. So axis of symmetry. Our x value for the axis of symmetry is equal to P plus Q divided by 2. Well, here's your P, there's your Q. We dump them in. So x equals 2 plus 2 divided by 2. Oh, this guy is -2. Q is -2. So 2 plus -2 gives us 0 on top over 2, which then comes out to be 0. So our axis of symmetry actually goes through the y-axis. So there's our axis of symmetry. And now we pretty much have everything drawn that we would need to kind of create this U shape. So this parabola. And so there, as we can see, is our U. Now notice it's a kind of a more narrow U shape, more narrow parabola. And that's because our A value is 2. And so that's why we see that vertical stretch happening there, where it's kind of thinner like that. Go ahead, feel free to pause the video if you have any questions at all. All right. Now let's go ahead and take a look at example 2. Here we have to find the zeros of the function and then sketch the graph. I'm going to go ahead and get us started, but then I want you to pause the video and give it a fair shot, okay? To find the zeros, zeros is another word, like we've said in the past, for x-intercepts. So anytime you hear a teacher say, hey, find the zeros, they're talking about x-intercepts or roots as well. Now, to do that, and there's like subtleties with that, but it's the general idea of finding the x-intercept. Now, to find the zeros or x-intercepts, again, here's your graph. You're trying to figure out where is it crossing this axis. Well, we know that the y value is always going to be 0 if it's crossing this x-axis. And that's exactly why, because it'll be like some point here and some point here, where your y value there is 0. Always 0. And so as a result, what we're going to do is take our function, and this guy is acting as y. We're going to set that part equal to 0. -2x squared minus 4x on the right side plus 6. And what I want you to do is, again, pause the video and try to solve for x. Now, we've talked about factoring, square root method, quadratic formula. So you have a lot of different options. Factoring might be the most ideal at quick glance, but you might have to use quadratic formula. So go ahead, pause the video, give it a fair shot, and then we'll come back together and see how we did. All right, now that you guys have had a fair chance, let's go ahead and see this. Some people might just jump right into factoring, which I think is great, but you have to be mindful. Notice they're all evenly divisible by 2. So we can always GCF then in that scenario. You always want to start off with GCF. Also, if this guy is negative, you kind of want to pull a negative out. So 0, it just makes your life way better and easier. So we can pull a -2 out of all of these terms. And so when we do that, if we pull the -2 out of this first guy, we'd have to have a +1 x squared. If we pull a -2 out of this middle term, or essentially if you divide it by -2, you get a +2x, right? Because again, you're dividing that by -2. And then +6 divided by -2, you would need -3 there to get that +6 again, right? That times that would give you +6. So there we have factored a GCF. And now the beautiful thing with GCFs being a constant like this -2 is we can divide both sides by -2. And boom, boom, it's gone. And when we do that, we have 1x squared plus 2x minus 3. Much simpler numbers. And then on the left side, 0 divided by anything is just 0. So now we have a much more manageable factor. And we know we can break this guy down. You can factor by splitting the middle term. We're going to use the shorter method on this one. What times what gives us this 1x squared? Well, 1x and 1x does that. And then what number times what number gives us 3? Well, we've got 1 and 3. 3 times 1 gives us 3, right? And then we're trying to get this b value of positive 2 in the middle. Well, then that would force this to be positive, because then I'd get positive 3x. And that would force this to be negative, because then I'd get negative 1x. So positive 3x and negative 1x. That gives us this positive 2x that we always need in the middle. Again, the only reason why we went this route is because the numbers were a little bit smaller. If you feel like you need to do splitting the middle term, feel free to go for it. All right. Now we have factored. We're going to go ahead and solve. This is where we split and solve. So 1x minus 1 equals 0. And 1x plus 3 is equal to 0. Doesn't matter which side the 0 is on. I just kind of did it because it's on the left side for now. And now we're going to go ahead and solve each one. So here we would add 1 to both sides. And it was 1 equals 1x. And divide the 1. X is 1. For this one, we would subtract the 3 over. Boom, boom. We get 1x equals negative 3. Divide the 1. X is negative 3. So it looks like our x-intercepts are 1, 0, and negative 3, 0. And these are the x-intercepts. Both of them are the x-intercept. All right, so now we go to plot those on the graph. So we said 1, 0, and negative 3, 0. Again, going by 2's. So 1, 0, negative 3, 0. Now we could find the y-intercept. I think you guys know how to do that at this point. So it's actually, oh, here we go. This one's actually very quick. So here's our function, f of x equals negative 2x squared minus 4x plus 6. Beautiful thing about standard form is when you're trying to find y-intercept, we've seen this in the past, you dump 0 in for the x, and pretty much all that first stuff is going to come out to be 0. And so it's really just that c value that we get, right? So f of 0, or the y-intercept, is 6. So 0, 6. It's really quick and easy with standard form. Now, if we tried with, intercept form, you'd actually have to plug it in and do the math then. But this one was nice and easy. So we have 0, 6 as our y-intercept. And now let's go ahead and find our axis of symmetry. So axis of symmetry. This is where we take our p, x equals p plus q divided by 2. And so our p and q are those values. So we end up with x equals 1 plus negative 3 divided by 2. And so then that gives us negative 2 on top divided by 2, which is negative 1. So let's redo that guy. Equals negative 1. So our axis of symmetry is at x equals negative 1. And boom, axis of symmetry, x equals -1. And then after we have that, we're going to go ahead and find the vertex. Last part, vertex. Well, now that we know x is -1, you can do it a couple different ways. We'll go ahead and just use the original. Usually that's the safest, is always using the original function, just in case at some point if anyone made an error, you can kind of avoid those other issues because you're using the original. So f of -1 is -2 times -1 squared is 1. -4 times -1 would be +4. And then -2 times 1 is -2. Bringing these together, we get 2 plus 6 is 8. So we have -1, 8 would be your vertex. And then looks like for the reflection, if you wanted to, we don't have to, but this would be -2, 6. A little bit more of an accurate U. And then we just create our parabola. And boom, there's your result. And again, we notice our A value is -2. And so that's why our parabola is going downward. And it's got that vertical stretch by a factor of 2 because, again, that A value is larger than 1. So it's kind of getting narrower there. Go ahead and feel free to pause the video if you have any questions at all. All right, moving on to example 3. Here we have a tennis ball is tossed from a balcony, and the height of the ball in feet can be modeled by this function, where x is the time in seconds after the ball is released, and we're asked to determine how long it would take for the ball to hit the ground. Well, it's said that it's tossed from a balcony. So imagine here's your person, they toss it, and then it goes down and hits the ground. So we're essentially trying to figure out at what time that's happening at. Now, generally speaking, that's going to be your x-intercepts. So as a result, we're going to take our y equals -4 times 2x plus 1 times the 2x minus 3. And we're going to set this equal to 0 so that our height, which is what y represents, is 0, because we want to know when does it hit the ground. And so we have -4, 2x plus 1 times 2x minus 3. Now, with this a value, being that it's a constant, we can divide the -4 on both sides. And in the end, it's still going to be 0 there. And then what we can do is we can then split and solve these. So we have 0 equals 2x plus 1 times the 2x minus 3. We're going to go ahead and split and solve each one of these. So we end up with 2x plus 1 equals 0, and 2x minus 3 equals 0. And then solving each one, we subtract 1 here. 2x equals -1, divide 2. We see that x is -1/2. On this one, where we would add 3, we get 2x equals 3, divide both sides by 2, and see that x is 3/2. And so we end up with these two different answers, -1/2 and 3/2, or 1.5 seconds. Now, let's look at our parabola again for a moment. Here's the person where they toss the ball up, and then it comes back down and then hits the ground, right? Well, looking at our two answers, the one that had the 3/2, +3/2, that is the value where it actually hits the ground. The -1/2 is still an x-intercept, but that would be occurring backwards in time. And since we can't really go backwards in time, there's kind of two trains of thought based on this question. But at time 3 seconds is when the ball would really hit the ground. And so that is how long it would take for the ball to hit the ground, because at time 0 is when it started, when the person launched it, and then 3/2 seconds or 1.5 seconds later, the ball hits the ground. On this one, I wouldn't try to take the mean, or I wouldn't try and take the full distance here. It's really kind of aiming for when this person releases the ball, how long does it take? So more of a realistic contextual question. And so for our final answer, after 1.5 seconds, our ball hits the ground. Ball hits the ground. So really, we're kind of only taking that answer. Then it asks, find the maximum height of the ball and the time that it takes the ball to reach this height. So to find the maximum height, we're talking about the vertex here. So we're looking for this vertex. And this is really where our x-intercepts, both of them, come in handy, because we're then trying to find what is the axis of symmetry to then find the vertex. So to find the axis of symmetry, we're going to take our P and our Q. Again, doesn't really matter which one's P and which one's Q. So I just said P is the -1/2, Q is the 3/2. So P is -1/2, Q is 3/2. And for our axis of symmetry, we know x is equal to P plus Q divided by 2. Always P plus Q divided by 2. We dump them in, we end up with -1/2 plus 3/2 all over 2. So we end up with x equals, looks like 2/2 over 2. So 1 over 2 in the end. So 1/2 seconds is when it's going to reach that axis of symmetry. And now we have to find the vertex, though. So we know the x value. Let's go ahead and find the y. So we'll simply just go ahead and plug this into our original function. Y equals -4 times 2 times 1/2 plus 1 times 2 times 1/2 minus 3. And then essentially we just kind of clean this up. So end up with y equals -4 times, this would be 1 plus 1, and then 2 times 1/2 would be 1 minus 3. So -4 times 2 times -2. And then ending up with, looks like a value of 16. So this would be -8 times -2 would be +16. So the vertex is 1/2 seconds. Our height's going to be 16. So 1/2 seconds, we would see it at that height, 16. So we've answered where is it going to be the maximum height at 16 feet. Our ball reaches the maximum height. And we've also found out at what time that happens at 0.5 seconds. Go ahead, feel free to pause the video if you have any questions at all on example 3. All right, now looking at example 4, these are kind of staple questions, I would say. You're pretty much given a parabola, and they're going to give you your x-intercepts oftentimes, and then another coordinate there. Sometimes you might actually have to discern that coordinate too, and that's kind of where the y-intercept comes in handy. Or you might have to look at a clean point on the graph to help you. And then we have to construct a quadratic function based upon that model. Now, in doing so as well, we're going to use y equals a times x minus p times x minus q, our intercept form for a quadratic. So what I'd love for you guys to do is quickly pause the video, kind of give it a fair shot, see what you can come up with, and then we'll come back together and see how we did.